So here's a look at possible solutions to the study team test from 2016 for chapter 6. First question says find the equation of the line that goes through two given points. So there's 2 points there on the Cartesian coordinate plane, and there's exactly one line that goes through them according to Euclidean geometry. So we're trying to identify that point, and what our general strategy has been is to find the slope of the line first and then use that slope in one of the 2 points to figure out the y-intercept. Then once you know both the slope and the y-intercept, you can write the equation of the line. So if you recall, slope is the change in y over change in x. And to find that, right, I'm going to use my y values. So here's a y value, and here's a y value. So if I'm looking at my change in my y values, I could, for example, say 3 minus 1. That's one way that I could write the change in my y's. And if I look at my x values, I'd say I've got an x that's 5 and an x that's a negative 5. So I'm going to follow that exact same pattern to figure out the change in x. So I'm going to start from the second point, which is a 5, and then I'm going to subtract the negative 5, the x from the first point. When I do that, my numerator ends up being the number 2, right? 3 minus 1 is 2. And 5 minus negative 5 is positive 10. So we get a slope that is equal to 1/5. And just to illustrate, it doesn't matter. If I would have flipped the order, I could have said, for example, slope was 1 minus 3. But if I did that, I'd have to do the opposite direction on the bottom as well. I have to flip it. So I would say that that's negative 5 minus 5. If I did that, you'll notice that the numerator is now negative 2 and my denominator is negative 10. Since they're both negative, I still get a slope of positive 1/5. So what's important is that we remember the order, right? Change in y over change in x. If I go 3 minus 1, then I have to go 5 minus negative 5. And I could go the other direction, but I just have to do it for both the numerator and denominator. Okay, so now that we know that our slope is 1/5, we need to figure out what our y-intercept is. So if I was to write the generic, the slope-intercept form of any equation, y equals mx plus b, and look at a particular point, I'm going to erase these colors, and I'm going to say, hey, here x is 5x, and y, I'll use this purple, is 3. And I already know that my slope, we figured out in the previous problem, my slope was the number 1/5. So if you look at it, I have substitutions for y, for m, and for x. What this is going to do is allow me to solve for b, my y-intercept. So let's go and plug in the y value that we have, right, from the point that we selected, the second point. Y is 3. M, my slope is 1/5, and x, from the point I selected, is the number 5, and then plus b. 1/5 times 5 is the number 1, so I get 3 equals 1 plus b. And if I take away 1 from both sides, we get that 2 is the number b. So b is 2, and our slope is 1/5. Therefore, the equation of this line is y equals 1/5 x, and then plus the number 2. Oops, off the screen there. Y equals 1/5 x plus 2.